Okay, let's look at some other examples. If I took a sample from a population and I know that this population has a mean of zero point 0.5, when I took my sample I might get something that has a mean of 0.52629. So it's a little bit different than what the population is. Now, when my sample mean came out to 0.52629, I can be 90% sure that the scores might fall in the range of 0.43 to 0.61. So even though this is my score, I can be 90% sure that if I were to do it again, it'd be within this range of 0.43 to 0.61. However, if I or someone else were to take another sample, I'd probably get something different. In fact, I know I'd get something different. So we can assume that if we were to do this over and over again, we get something like this table. And this table is available in your notes. So here's my first time. Sample number 1, this is my mean, and I have a confidence interval, and I'm 90% sure that that mean is somewhere within this range, that all the scores are in this range. So does it contain the population 0.5? Yes. And in fact, on number 2, even though the mean is different, we still get a range, and the range of my set of scores contains the parameter score of 0.5. So once again, it does. So I keep doing this over and over and over. Get down to number 9, and this time my mean is 0.63, and the confidence interval is 0.58 to 0.68. This is the lowest, this is the highest. So this time it doesn't contain that. So one time out of 10, it doesn't work. As we said, this is a 90% confidence interval. That means 90% of the time, the scores of the means from our sample will be close to this 0.5, and this always gives us a range. One time out of 10, this time out of 10, for example, it doesn't work. And we're willing to live with that. So if we keep going down through this, well, here's another set of scores where the range from the lowest score to the highest score for this set of scores is above what the population mean is. So 2 times out of 20, or 90% of the time, it doesn't work. One of the questions people often ask about this is, well, how do you know? We don't. If we knew, we wouldn't have to do this. This is an estimate. And people also ask, well, how does this happen? Well, the computer does it. Just assume for this class right now, a miracle occurs. That's where this confidence interval comes from. Now, if I had a 95% or a 99% confidence interval, that would mean that it was more sure which set of scores that this came from. And more than likely, as you saw from the Coke and Pepsi demonstration, it would, if you wanted it to be more accurate, it's going to have a wider set of scores to work from in order to figure out whether or not your sample really represents the population. If the number is small, there's less variation in the sample and is likely to better represent the population or show a difference. So there's lots of things that you have to consider: the range of the scores and the confidence interval. And those two things together help you determine how good of a job the person presenting this data did with this. Give an example of how this works, or what this would look like in an article. You see down here at the bottom of this, it says by 18 months of age, 96% the confidence interval, 95% confidence interval of 94 to 98% of normal children reported to recognize the television image of a cat, dog, or baby, compared with 19% of the 18-month-old children. So what this means is, if we were to do this over and over and over, 95% of the time, somewhere between 94% of the kids and 98% of the kids would be able to recognize these images. So this is the average score, and it knows that 95% of the time, if it were to do it an infinity number of times, between 94 and 98% of the kids would be able to recognize the images. So this confidence interval gives us a portrait of how good of a job they've done with this 96% being able to recognize it. So once again, by 18 months of age, 96% of them can read it or can recognize the image. And if we were to do it over and over and over, 95% of the time, between 94 and 98% of the kids would be able to do it. That means 5% of the time, the range would be somewhere one side or the other of this, either below 94 or above 98%.